All right, let's do something that's a little bit more difficult for you here. Okay, so here it is. It's sliding to the left. Let's draw a picture of it. Here it is, sliding to the left. Okay, you can almost see it moving to the left. There it is, right? I exert 3.5 newtons to the right. So let's draw a picture of that force. Okay, it's to the right, and everything to the right is going to be positive. So I'm going to make that a positive force, right? Now we got to think about the force of friction, the kinetic force of friction, right? In part 0, we calculated that it was 4.998. Don't get this wrong, by the way. If you get that like first part wrong, basically the rest of the problem is just totally messed up. Okay, now if it's sliding to the left, this gives us a clue as to which way this guy is. Okay, if it's sliding to the left, this guy will be to the right. Okay, these guys are always in opposite directions. So if it's sliding to the left, the friction's to the right. If it's sliding to the right, friction will be to the left. Okay, so let's draw that force in here. Okay, so here is, I'm going to draw it slightly longer, right? So here's our 4.998 newtons. And that guy also would be positive. So now the question is, how does this block slide to the left if two forces are acting to the right and there is no force acting to the left? And the answer to that is that, well, it's going to slow down and stop, right? But it continues to do that because it's got inertia, it's got kinetic energy, it's got momentum. That's the tendency of objects, is to resist a change in motion, right? Okay, so this is supposed to be, what is this? This is like an arrow. Everything to the right is positive. So we're going to make those guys positive. Our F equals ma looks like this: plus 3.5 plus 4.998 equals 4.25 times A. Okay, now we're all set. 3.5 plus 4.998 is 8.498 equals 4.25A. And then I'm going to divide both sides by 4.25. So divided by 4.25, that is A is equal to positive, it's 1.9995. So I'm just going to say 2.00 meters per second squared. Okay. Now think about this, right? It's sliding to the left, but it has an acceleration to the right. So this means that it's decelerating. It's going slower. Yeah. It's going slower and slower and slower. It's decelerating. Yeah, that's kind of cool. Of course, that makes sense, right? The reason why it's still a positive acceleration, though, and we're decelerating, is that because its velocity is to the left, you need a positive acceleration to actually be stopping.